So what we are primarily doing here is let's say you've got, and I'll take two different colors to probably explain it. So let's say you've got a curve like this, and let's say you've got a curve like this, right? And I'm asked to find the area between the curve, that's the area. So if I take this down, so this is, let's say, A, I take this down, this is B. I'm asked to find the area between the curve, not under the curve, between two intervals. Okay? So now, let's say this is, the black one is a function f of x, and the green one is a function g of x. Now, in this scenario, your f of x is more positive or greater than g of x, right? Because it's up, it's higher than g of x. So can I say my f of x is greater than g of x in this scenario?
Yeah.
Yes? All good? Now the area of the region, that's called the region, the area of the region between the two curves, when you've got two curves where one is greater than the other, is basically the definite integral between the points where I'm trying to find the area, f of x, the stuff which is the area with the curve which is higher, take away the g of x. That's the area between the curves. Or if you want, and dx obviously. And you can also say it like that, a to b f of x dx minus a to b g of x dx. Right? Make sense?
Yeah.
If you've learned that in the school, then pretty much that's what it is. Right? Now let's take a practical example and try to understand that. May I take this off the board, please?
Yeah.
All right. So let's take an example where we're saying let's say it's passing from the origin, and the other one is so this curve is, the black curve is y equals to 2x, and the green curve is y equals to x squared. And I'm asked to find, and let's say the points, this is the point O or 0, and that's the point P. So I am asked to find the area of the region between the two curves. So where are the two areas, two graphs intersecting? At 0 and at this point, right? Which must be here. Correct? How do I find this point? Can someone tell me?
2x equals x squared.
Good job. So I just equate both of them. So I say x squared equals to 2x. So x squared minus 2x equals to 0. X common, x minus 2. X equals to 0, x equals to 2. There are many ways of doing it, right? You can cancel one and say x equals to 2 as well. There are many ways of algebraically doing that, right? But factorization is the best way to do it, right? That's what they expect you to do, I tell you. You could have said x squared minus 2x and you cancel x and say x equals to 2. But you just get one value here. There are actually two values. Factorization gives you two values. Okay? Mind you, don't do that. Don't do that. Yeah, makes sense?
Yeah.
All right. Now, so I have to find the integral between 0 to 2 because that's 2 now. If you look here, Kisha, on the region, which graph is higher? The black or the green?
The black one.
The black. Black is 2x. Yes, Ayushka?
Yeah.
Right? So what you would say is 2x minus x squared dx. That's the area between the area of the region between the two curves. And then what would this be? What's the integral of 2x? X squared? And not like this or not like this?
It's x squared, yeah.
Come on. 2x dx. 2 goes out. X dx. X 1 plus 1 over 2 times 2, which is x squared, no? Basic integration.
Yeah.
Kisha, yes?
Yeah.
Right? And what's the integral of x squared dx? Chris?
X cubed on 3.
X cubed on 3, bang on. See, you can split it. You can say, okay, this dx minus this dx, eventually you'll land at the same spot. Right? But it's good to do it together. You save some time there. And then, let's plug stuff in. 2. If I plug in 2 here, so which is? What's that? 4 minus, what's 2? 8 over 3. If I plug in 2, take away 0 minus becomes plus 0. So basically 4 minus 8 over 3. And the answer would be 4 over 3. Let's say you've got something like this, and this is interesting.
What was the answer again?
4 over 3. Now, let's say, Chris, you've got something like this. And the other curve is right, and I say you need to find the areas from this point is, let's say, A, and this intersection is C1. From this intersection to this intersection, C2. From this intersection to this intersection, C3, and let's say to this point, B. Right, so what you're trying to find is this. I got the colors. That's what you're supposed to find. All right. So now, let's say this is, the black one is a G and the green one is an F of x, right? So this is f of x and this is g of x, right? So from A to C1, from A to C1, which graph is higher?
G of x.
Look again. From A to C1, just this block. The green is higher or the black is higher? Here, just here.
Green.
Green. Green is f of x. So I will say f of x minus g of x between A to C1 dx. Right? Now, Kisha, so I'll say now plus from C1 to C2. Which graph is higher? G of x. So I'll say integral C1 to C2 G of x minus f of x dx plus Ayushka
Yeah.
from C1 to C2. Oh, sorry, from C2 to C3. Which is higher?
F of x.
F of x. So I'll say f of x minus g of x dx. And back to Chris. Addition of from C3 to B.
G of x minus f of x.
G of x minus f of x dx. That is the area of the region. Super important. Make sense?
Yeah.
Now, let's say you have a question, and I'll write it here. Let's say you've got a curve like this, and I'll take another color, and you've got a curve like this. And you're supposed to find this area. I'll give you a few more clues here. So let's say this is the cubic, which is y equals to x cube, and this is a straight line, which is y equals to x. Now, can you find the area of the red region? For using the concept that we just talked about, you need to find the intersection points. If you get the intersection points right, you're there. So you have 3 points here. When you say x cube equals to x, Kisha, factorization is important, and you say x square minus 1 equals to 0, x equals to 0, and x square equals to 1, so x equals to plus 1 plus minus 1. So you have minus 1, 0, plus 1. So which essentially means that this point here will be minus 1, that's 0, and that's plus 1. Now half the battle is won. So which essentially means that this point here will be minus 1, that's 0, and that's plus 1. Now half the battle is won. What needs to sit underneath, what needs to go over between the intervals is something that you need to figure out. Even if you don't get the answer right, at least do this stuff. Do this, make the integrals and show you're working out. Don't worry about the final answer. You still get marks for your understanding, provided you are able to get that over the line. Until what point? Have you been able to find the answer, Ayushka?
No.
No. All right. Cool. Let's don't chuck it off. Don't cut off anything from your notebook. Let's see where we landed. So we have these 3 points. If you look at the graph here, negative. So first is -1 to 0. Basically 0 to -1. Right. So I'll say integral of -1 to 0 because negative 1 is smaller than 0. Now here my cubic is above my linear. So I will say x cube minus x dx. Is the first step right for everyone here?
Yeah.
Yes? And then I say plus from 0 to 1, I have my linear above cubic. So I will say x minus x cube dx from 0 to 1. All good? So far, who's done this right? If this is not correct, there's no point anything further down. Kisha, did you get this?
Yeah.
Did you write this? If you've not, then did you understand this? Ayushka? Yes? Now, let's solve it. What's x cube? X cube is x4 over 4. And what is x? X square over 2. Between negative 1 to 0. Did you do this, Ayushka?
Yeah.
Did you get these values here?
I forgot to anti-differentiate. I just.
Okay, cool. But you need to do it, right? Kisha, you're fine? Even if you're not, then you are understanding this now, right? Now, what's x here? X is x square over 2 minus what is cube? X 4 over 4 from 0 to 1. If this is incorrect, the next steps are gone. Even if you goof up here, but this is fine, you still get marks. But if you don't goof up here, no one can help. And it's very straightforward. Look which graph is up. That comes first. Take away which graph is down. Both of you, did you understand why this is x cube minus x? Ask. If you don't ask. Kisha, no.
No.
Ask. No, ask. That's fine.
Is it because like the thing is on top, so it would.
Forget about everything. Just look at this portion. Just look at this portion. Is black greater or green greater?
Black is greater.
Because it's sitting above.
Yeah.
So black is x cube. So that comes first.
Okay.
Minus the green, which is the x. Now look here. And I have to add. In the second circle, is black greater or the green greater?
The green one.
Green is x.
Yeah.
Take away the black, x cube dx. That's how you do it. If you look here, in this interval, is green greater or black greater?
The green one.
Green. So we say, and the green was f of x, and the black was g of x. So we said green minus black.
Ah, okay.
And in this area, is black greater or the green greater?
Black.
Black. Black was g of x. Take away f of x. Just ask a question from yourself. Who's sitting on top of whom? Aishka, does that make sense?
Yeah.
Now, if you just have to just do the fractions from here. Chris, I'm guessing all of this was right for you. I hope you want me to solve this as well, guys.
No, it's okay now.
All good?
Yeah.
All right. Oh, somewhere something's incorrect. All right. Quick, one more. You've got That's the area you need to find. The black graph is y equals to cos x, and the green graph is obviously y equals to, sorry, did I make it incorrect? Y equals to sin x. And this is 0, this is pi, and this is pi over 2, this is 3 pi over 2, and this is 2 pi. Now we got, it says find the area of the shaded region. So basically from here to here. The most important aspect is finding the interval. So I'm eagerly waiting for you to give me the interval. That is the interval I'm after. Just look at, if I just now take away everything. Now tell me, who's above whom?
Sine.
Is not sine above cos?
Yeah.
Right? So it's sine x minus cos x, basically.
So are
So
we
the
still?
area of will be something something sine x minus cos x dx.
Are
That's
we
the
also
area.
finding that second section from 3 pi to pi? 3 pi to
No,
2?
I just said
Oh, okay.
to this point, not even here.
Okay.
So this is where they're meeting now. That is what I'm after. And in that interval, I need to find, if I take all of that crap off here, it's confusing. I need to find what point is this and what point is this. Right, I need to find these 2 points. Here to here. And that's what will sit at these 2 spots. Now, I want to see how much of circular do you remember? I need the spots. First of all, give me the intersection points, please. Chris,
Pi on 4 and 5 pi on 4.
go ahead. So it's pi on 4 and 5 pi on 4. Now, who needs this explanation? I'm happy to do that. Because after that, you can do it. We'll start probability next week. Ayushka and Kisha, did you get this? Did you solve these points and did you get this?
Yeah.
Yeah? Kisha? Did you know how to get 5 pi by 4 and 5 pi by 4?
No, I'm not sure.
Alright, then ask, that's fine. It's okay to ask. See, well, you have two equations. How do you find the intersection points? You equate them, correct? That's what we've been doing so far. So let's equate them. So I'll say sine x equals to cos x, correct? So can I say sine x over cos x equals to 1?
Yeah.
What is sine x over cos x? Is it not tan x? Sine x over cos x is tan x. Okay? So you should know that. Sine x over cos x is tan x. Now where is tan 1? At pi by 4. If you need, from your bound reference, you can come to know that in the first quadrant, your tan pi by 4 is 1. Correct, Chris? Now that's your first quadrant value. Pi by 4. A, S, T, C. All signs positive, sine positive, tan positive, cos positive. This is a positive one. So the first one is a pi by 4. And the second one is the third quadrant. And third quadrant is pi plus theta. Theta is pi by 4. So that means pi plus pi by 4 is 5 pi by 4. So that means this value here must be pi by 4 and that value must be 5 pi by 4. That is why they come here. And when you look here, your green is above the black. Green is sine. Sine minus the black, cos dx. You then end up solving this to find the area under the area between the two curves.
What's the
Aishka?
answer? What's the answer?
Chris, what's the answer?
I think I got 2 times root 2.
2 root 2 is the answer. What did you get?
I got 2 root 2 divided by 2.
2, so root 2 basically. Did you get 4 over root 2? See, you can get 4 over root 2, which maps to this value.
Oh.
That gives me root 2, not 2 root 2. 2 and 2 can cancel there. Tisha, is this clear? The
Yeah.
concept is clear?
Yeah.
Right? Now, let's look here. Sin x is what? If I come here now. Sin x is negative cos x. Yes, Chris? And cos x is positive sin x, which is negative sin x here. From pi by 4 to 5 pi by 4. Yes? And then you just solve it, get the answer.
Is negative cos 5 pi over 4, is that just root 2 over 2? Or not?
Yeah, 1 over root 2.
Is it negative or positive? Because it's negative cos. So it's negative, right?
Third quadrant, negative. Because we're talking about cos. Cos and sine both are negative, that makes tan as positive.
Okay.
So whatever is 5 pi by 4, you will have negative values for sine and cos. Right? And for pi by 4, you will have positive values. Of all of them are what? 1 over root 2, right? Because they're reference angles, right?
Yeah.
So for pi by 4s, it will be positive 1 over root 2. For 5 pi by 4, it will be negative 1 over root 2.
Okay.
Alright? Does that make sense? Yes?
Yeah.
Now, let's do the last probably bit of integral from a concept standpoint. It's called the average, finding the average value of the function. or the average rate of change. No, not the rate of change, the average value of the function. So if you have a function like this, and let's say you've got something like this, and I say this is A here, and probably a B here, so that you have something like this, let's say between A and B at that value of y. So if you're trying to find this, the average value of the function between A and B, so it will be 1 over B minus A f of x dx, and let's say this is f of x between A and B. That is the average value of any function. Of any function. What is average? Average is the total divided by the count. Yes or no? Average is mean, right? In very basic term, what is mean? Mean is when you add all of that and divide it by the count. Correct? So if I have 1, 2, 3, 4, and I say find me the average, so you'll say okay, 1 plus 2 plus 3 plus 4 divided by 4. Right or wrong? So you started from the 0th value, you went to the 4th, you started from here and you covered 4 values. So basically 0 minus 4, no? So 0 minus, that's what it is. B minus A. Sorry, 4 minus 0. 4 minus 0. So that's what it is. That's the count. And integration is the summation. Your word, this symbol is actually the sigma sign. Sigma sign means add everything. So that's the addition, which is this part. And this is the count. That is why we call it as an average. So you find the average, it's all connected, right? So the formula is the same, right? Any function of any type, any curve, if you were to find the average of that, just take the integral between the definite integral that gives the area under the curve and you divide it by the intervals, the count.
Are we gonna be doing rates of change and stuff?
Is it here in the book?
Yeah.
Yeah. The rate of change is this bit here. Now, I think I'll spend some more time next week doing the rate of change, acceleration, motion, right? All of that, right? And we'll do a bit more of rate of change, and we'll do a bit more questions on that, and then we'll move to probability. So next week probably we'll spend first half an hour understanding what is velocity, what is acceleration, and how they're connected to integral and rate of change and differential, right? Oh, good. So we'll finish integration next week, first half, and we'll jump on to probability, the last leg in the game, right? All right, cool. Thank you.